Welcome! In this video, we will evaluate the integral of 1 over x times the square root of x squared minus 1. We'll use a classic trigonometric substitution to make the square root simpler. Notice the expression x squared minus 1 inside the square root. That suggests a secant substitution. Let x equal secant theta. Then the square root of x squared minus 1 becomes the square root of secant squared theta minus 1, which equals tangent theta. Now compute the differential. If x equals secant theta, then dx equals secant theta tangent theta d theta. We'll substitute these into the integral. Let's rewrite the integral in terms of theta. We replace x with secant theta, the square root with tangent theta, and dx with secant theta tangent theta d theta. Watch how everything cancels. Since the square root of secant squared theta minus 1 is tangent theta, the integral becomes a very simple integral of 1. So we get the integral of d theta. The integral of d theta is just theta plus c. Now we need to convert back to x. From our substitution, x equals secant theta, so theta equals arcsecant of x. We can also write this as arc cosine of 1 over x. Let's write the final answer. Final answer. The integral is arcsecant of x plus c.